one of the pieces of importance with regard to calculus is its ability to describe things in terms of motion. And so we're going to consider just straight line motion. And what we mean by straight line motion are things that are moving either horizontally, right, or vertically. We're not considering any type of diagonal motion or anything like that, right? So we're just keeping it simple, considering motion simply along a straight line. And it's interesting how even just that can be complicated. Now, standard notation, when we're thinking about this, is say that the position function, where something is on some given straight line, is always typically denoted by s of t. So the position s of the function at a certain time t. So for example, we could say that this is a position function, s of t is equal to t squared minus 2t minus 3, where t is in seconds. And this function would just tell us the location of something on some number line at different values of t. Right, so that's just the situation. So consider s of 0. This is when time is 0, or when we're starting to look at some process, where is some particle at? We would find that s of 0 would be negative 3. So what that would mean in terms of a picture, let's say we're describing only straight line motion. There is a particle, and it's starting at negative 3. And then we might wonder, well, what happens 1 second later, or what is s of 1? And s of 1 would be equal to, what's that, 1 minus 2 minus 3, which is negative 4. So that means our particle started at negative 3. And 1 second later, it's at negative 4. So it would seem like, based on that data, in that first second, the particle traveled in this direction. Or at some point, was at least traveling in that direction. S of 2, for that same function, would tell us that the particle is now, let's see, 4 minus 3. So it's back at negative 3. So what this means in terms of a picture was our function, our piece started at negative 3, and 1 second later it was at negative 4, and then in the next second it traveled back to negative 3. Okay, well, what's happening at s of 3 and s of 4? Well, the third second this particle has been traveling, it's now at 9 minus 6 minus 3. It's now at 0. S of 4, well, that would be 16 minus 8 minus 3, where it's now at 5. So if we were to model the whole movement along our number line, the particle started at negative 3, or whatever it is we're talking about, and in the first second moved to negative 4, and in the second second, moved back to negative 3. In the third second, it moved all the way to 0. And in the fourth second, it moved all the way out to 5. So it would even, so we can see a couple things just in terms of our picture. We know that the particle changed direction, and in each subsequent second, it was covering more ground than it had in previous seconds. So we can see that it's changing, it's getting faster in a certain sense. Right? And we can see all of these things. So that's the idea of position function, and in the next section we're going to talk about velocity.